Hey guys, today we're doing problem number 54 from the book. It's basically about this kid going down a slide and he's being pulled by a rope and he has a few forces acting on him. Our job is to figure out the value of the normal force, and we're gonna go ahead and approach that by looking at the diagram directly from the book. Here's a crude little drawing of the kid, our horizontal rope, and the slide that forms an angle of 38 degrees with the ground, assuming it's perfectly horizontal. I just went ahead and dropped a line down from the rope and marked this angle right here, 52 degrees, because that's a right angle forming with the ground, and complementary angles add up to 90 degrees. So to go further with this problem, we want a free body diagram. Our free body diagram I've drawn right here. The book mentions that there is a frictional force from kinetic friction, normal force, what we're trying to find, the horizontal tension, and the weight dropping directly down. This dotted line, it's not a force, it's just the slide that I wanted to draw in, and I put the 38 degrees in there. And as we can see, none of these forces are acting in opposite directions. So we can't do math or like vector addition or anything with it. We need to break some forces down into their components. So I'm going to break down the weight and the tension into its x and y components. And here's another free body diagram that I drew with its components labeled. We have our frictional force again, normal force, and what we see here is that the x components of both tension and weight are acting in the direction opposite from the frictional force. So these two forces, or components of the forces, are making the child move down the slide. And we see that the y component of the weight is opposite to the normal force and the y component of the tension. Now the kid obviously isn't, coming off the slide or anything. He's staying on the slide. He's not going up, he's not going down, staying right on it. So we can assume from that the sum of the normal force and the y component of the tension is equal to the y component of the weight. Now we know the values of weight, and we can figure out the y component by multiplying the weight times cosine of the angle, 38. And likewise, we can figure out the y component of the tension, which we know the value of from the book, and multiplying by cosine of the angle, 52. So that's exactly what I've done over here. The y component of the weight equals the normal force plus the y component of the tension. And I just broke that down a little more. Weight times the cosine of 38 from this little diagram right here equals the normal force plus tension times cosine of 52. Like I said, the complementary angle to 38. And again, breaking down even more, mg cosine of 38 equals normal force plus the tension times cosine of 52. And here we're going to start inputting values. 23, which is given is the mass of the boy, 23 kilograms times 10, value of gravity, cosine of 38 equals normal force plus 30, 30 newtons is the value for the tension given in the book, cosine of 52. Basically just plugging and chugging, going into your calculator, you get that the normal force equals about 162.773 newtons.